All right. Okay, let's review just for a second here. How many degrees are in a triangle? Like, what do all our angles have to add to?
180.
Yeah, 180. Now, we're going to try to look at a quadrilateral, so that's 4 sides. And we can actually split this into 2 triangles. So then how many degrees would be in here?
36.
Right, 2 times 180 is 360. And I would definitely probably at least just write down how many degrees are in each one, just because that will be helpful later on. Now if we move to a pentagon, so something that has 5 sides, we can split it into 3 triangles. So how many degrees would be in that shape?
540.
540. And then lastly here we have a hexagon. Do you guys have any ideas how many triangles we can split this into? 4. So 4 times 180 gives us what?
720.
720. So we actually have a formula to help us figure out how many degrees are in a polygon. And that's what we're going to write down next. That page. There we go. So our formula is n minus 2 times 180, where n equals the number of sides that our polygon has. N minus 2 times 180. This part right here, this n minus 2 tells us how many triangles are technically in our polygon, and then times 180 gives us the sum. Does that kind of make sense? Now we're just going to try a bunch of random problems with this idea. So the first one, it's kind of like finding the missing angle of a triangle, but this time we have a heptagon, because there's 1, 2, 3, 4, 5, 6, 7 sides. So first we have to figure out how many degrees are in a 7-sided figure, right? So we're going to plug into our formula 7 minus 2 times 180. You can just type that in your calculator, or you can simplify it a little bit. So we know 7 minus 2 is just 5. 900? Perfect. And now all you have to do is subtract away these 6 angles from 900 and see what we get. So don't forget, though, what does this box mean in the corner? 90. Don't forget about that 90. So let's all take a second and subtract away, and we'll see if we get the same answer. Lots of opportunities to type in the wrong angle, so just take your time. We'll see if we get the same thing. 140?
130.
130? 130? Anyone else for 130? I think it is for sure 130. Good. Typing. Yep, we just subtracted away from our total sum. Okay, so this next one wants us to find just one of those angles in a regular octagon. So if you kind of forgot what regular means, it just means that all of your angles and sides are the same. So all of these angles are the exact same in here. And we just want to find what one of them would measure. So first, let's figure out how many degrees are in an octagon. So we're going to plug into our formula. 8 minus 2 times 180. See what we get for that. $1,080. I agree. So now all of these in here have to add to 1,080, but they're all the same number. So what do we have to do to that 1,080 to figure out what one angle would be?
Divided by 8.
Yeah, divided by how many angles we have. So 1080 divided by 8 gives us what, folks? 135. So every angle in here is the exact same. We actually have a formula for this. And it's exactly what we just did. We first find how many total degrees are in our polygon. It's the same formula we've been using. Oh, yeah, it's on the next page. Sorry, kids. And then we just divide it by how many sides we have. If you're looking for just one angle in a regular polygon, you take the total sum and divide by how many sides we have. Okay, so let's try another one with this formula. So we're just looking for one interior angle of a decagon. So we have to figure out how many sides are a decagon. 10, right? Think of like a decade, 10 years. So we're going to plug in 10 to that formula. 10 minus 2 times 180 all over 10. And now we just simplify our way through it. We know 10 minus 2 is 8. Someone might have to refresh. No, it's 8 times 180.
1,440.
Okay, 1,440 divided by 10. 144? Woo! 144. That kind of makes sense. Okay? It's just so quiet today. Okay, now we're going to shift gears to talk about the outside angles, our exterior angles. So do you guys see, I know this picture's kind of hard, but like here would be our shape, right? Here's our pentagon, and we've been working with these angles on the inside, but now we're going to look on the ones on the outside, okay? And if I take all of those angles on the outside and put them together, what shape do they kind of make here? A circle, right. Do you guys know how many degrees are in a circle? If I spin around, how many degrees did I go?
360.
So it doesn't matter how many sides your shape has, the exterior angles always add to 360. There's no other formula to it, it's just, oops. Well, this is just silly. 360 is our formula. 360. All the outside angles always add to 360. Doesn't matter if it's a triangle or a 30-sided figure, they'll always add to 360. So on this next one, we're just looking for the missing outside angle here, this y. So what do all of these have to add to? 360. All right, so you can just subtract away. Then we can compare what we get. Let me know. I don't remember.
I think I know what it is.
Do you? What'd you get?
125.
Okay, same thing. Anyone else? 125?
I think it's negative 91.
Woo! I don't know. Hit the wrong button. Maybe this is answer.
Answer.
And yeah, so it's at 360. Let's redo it.
What did I use for the answer?
I wrote it wrong.
Find out. Oh, okay, find out.
360 and subtract away. Miss Nye, did you get 125? Elijah, you good with 125? Super. Woohoo! We all got 125. Okay, if we wanted to find one exterior of a regular polygon, so all of these angles here would be the same, what would we have to do to our 360? If they all have to be the same.
Divide it by.
Yeah, divided by how many that there are. So there's 5 angles there, so what's 360 divided by 5? Yes. You're on it today. So our generic formula for that would just be 360 divided by how many sides we have. 360 divided by however many sides we have. So then our last one's pretty straightforward. Find the measure of one exterior angle of a regular 20gon. We're gonna take 360 and divide it by what, you guys? 20. What do we get? 18. Beautiful. Good work. We'll start this salmon colored worksheet together and get a good start on it. Okay, let's grab the worksheet here. Okay, so 1 through 4, we're just writing down the formula we would use given the description. So if we wanted to find what all the angles of a polygon add to on the inside, that's just our n minus 2 times 180. N minus 2 times 180. What do all the outside angles add to? 360. If we want just one interior angle of a regular polygon, we take our sum and divide it by however many sides we have. So n minus 2 times 180 all over n. Kind of like if we want one exterior angle, 360 divided by however many sides we have. Okay, number 5, find the measure of angle 1. Okay, how many degrees are in triangle, folks? So let's subtract away 180 minus 40 minus 65. 75 is correct. What about a quadrilateral? What do those have to add to? 360. So we can subtract away. Tell me what you get.
64.
64? Okay, on 7, are those inside or outside angles? Outside, so we know they add to. All right, let's subtract away.
$70.
70 even? Perfect. Same thing on 8, those are outside angles as well.
$42.
42? Okay, super. Okay, we'll do one more, then I'll let you loose. So on these last 6 on the front page, you're using the same formula. We're looking for what all the angles inside the polygon add to, so the sum. So we're just plugging into this formula here. So on number 9, how many sides do we have?
6.
6, right? So we're gonna plug in 6 minus 2 times 180. 720. Now you're gonna do that for the other 5 on the front page. And there's a few on the back to do. Wave me over when you need me, I'll walk around. Turn off the recording.